Alright folks, we're here at the last lesson for the transfer of energy. We've looked at radiation transfer, we've looked at conduction of energy, and now we're looking at something called convection currents. So, I'm going to go back into my kitchen, I'm going to boil some water, and we're going to talk about how the particles are moving and the heat transfer through convection. Alright, so we're back here at the stove. I'm going to go ahead and turn it on to high, and you're going to see a stove coming on here. So just reviewing a little bit from yesterday, remember this is our radiation. This is radiation, so it's emitting those electromagnetic waves, and I can feel the temperature away from it because it's throwing those into the air, and since it's warmer, it's emitting more of those. And then I'm going to put this pot on here where we have conduction. So the particles in the pot, it is a solid, so those particles are getting energized and they're bumping into each other, transferring that energy. What we're talking about today, though, is something called convection. So the definition of convection is the transfer of thermal energy by the movement of the particles from one part of a material to another. So, as things heat up, remember, as we transfer from one phase to another, the particles become less dense and spread apart. So as we insert heat into an object, those particles are going to start spreading apart. So they become less dense. I'm going to put some water in here. Okay, so what's happening in the water right now? The top of the water has cold water, and what's in contact with the bottom of the pot, that's going to be much warmer water. So, those particles in the bottom, they're going to get more spread out a lot faster than the ones at the top. So they're getting spread out and less dense. If it's less dense, it's going to start floating. So that energy, that water on the bottom is going to start floating towards the top, which pushes this colder water that's on top down towards the bottom. So we start getting this circular flow of energy. Now, we're going to wait for this to start boiling, because that'll give you a little bit of a visual representation of what is happening here. Alright, so as this water is coming to a boil, you can see the bubbles at the bottom are floating towards the top. So, remember, things as you insert thermal energy, it goes from solid to liquid to gas as it equips more thermal energy. So those particles are getting more and more spread out, causing it to go to a different phase of matter. So the liquid at the bottom of this pot has a lot more thermal energy. It's a lot hotter down there. So it's going to spread those particles out and move them towards the top. This is turning it into a gas, but that is less dense and it's moving towards the top. This cooler water, relatively cooler water on top, is then being pushed down where it's going to hit the bottom of the pot, be exposed to the high temperature, and turn into a gas and float up again as well. So, cold water will sink, the hot water will float, and it just circles around and around and around, spreading the heat until the liquid is a homogeneous temperature all throughout. Alright, let's stop this. Alright, so convection. We have the cold water that was on top. At the bottom of the pot, it was exposed to the high temperatures because the stove was radiating thermal energy, which is being conducted through the pot. That pot was transferring that energy into the water, which heated it up. So this water at the bottom was floating towards the top because it had less dense. It was less dense because it had more thermal energy pushing those particles away from each other. So those less dense particles floated towards the top. At the top of the bowl, it was cooler water. So those were more densely packed particles, so they're going to start to sink. We start getting this circular motion as it goes from hot, raises up to cold, then it sinks again to get hot, and then raises up, and we're getting this circular motion. That is convection. Convection is the transfer of that energy in that circular pattern with the less dense particles floating towards the top and more dense going towards the bottom. Now we're going to look at this on paper, and I'm going to have a few illustrations. Hopefully get this a little more clear if you didn't get this from the example I just showed you, but that is convection currents. All right, so we're still looking at convection currents. So remember, convection is the transfer of thermal energy by the movement of particles from one part of a material to another. That is convection. So this is my crude drawing of a bucket of water suspended over a Bunsen burner. So we're heating up the bottom here. So at the bottom, we have hot. And at the top, this liquid at top, so compared to the bottom, it is cold. So remember, hot things, they're particles. They're spread out. They are full of energy, so they start spreading out. So they become less dense. They become less dense as they spread out. Cold, up here, you can see they don't have much energy. They're all packed tightly together. They're so dense that they're all packed tightly together. That's when it's cold. Hot is spread out and less dense. Cold is close together and dense. So in this sense, I'm heating up the bottom. These are so much less dense that they're going to start to float upwards. And these are so dense up here that they're going to start sinking down. So now we're going to have all of these particles at the bottom. So they're next to the fire, so they're going to turn hot, and they're going to go up, become cold, and then they're going to go down. So we get this circular pattern as it goes from hot to cold to hot to cold, and it's just mixing these temperatures around because the heat is coming from the bottom. It becomes less dense, it floats up, becomes cooler, and sinks back down. Convection currents. So remember, transferring the thermal energy by the movement of particles from one part of a substance to another. All right, let's hit another example. Say you are in a room, and that room is on fire. So you're in a flaming room. Nice room here. Now, every fire safety video I'm sure you've ever watched has told you, if you're in a flaming building, get down low. That is because we have our fires and there's emitting smoke. So, fire, that's our source of heat. It's heating up the particles in the air. And all that smoke that's coming off is very hot. So it's filling up the top of this room. Because remember, hot particles are going to rise because they're less dense. So if we stay down low here, then we're not going to be suffocating from the smoke because we're down low where the air actually is fresh. Because hot air rises, cool air falls. Because these fires are emitting this hot smoke, so it's going to rise, and we're going to stay at the bottom where cool air will fall and it's fresh air. That's why they always say, in a house fire, stay low. Another example of convection currents. This one, we're going to call back a little bit to when we were talking about tectonic plates, which I know was a really long time ago. But we have, let me look some. All right, so we have the Earth, and it's split into three parts. Remember, we have the core and the mantle, which is all this area. And then the outside is the crust. So the further in, the hotter you get. So it's actually, remember, our core is solid, and this mantle is a liquid. So here near the bottom, it's heating up the mantle, which is going to cause this liquid magma to rise towards the surface. And then it's going to start to cool a little bit, so it's going to circle around and start to fall again. We have convection currents within the Earth's mantle. Now, these are important because our crust is split into tectonic plates. And because the mantle is swirling around like this, it has this convection current going. it's actually causing the tectonic plates to shift and move. That's why they shift and move, is because the Earth's mantle is loose and going through these convection current cycles. So it causes earthquakes and it causes mountain ranges to form. It's all because of these convection currents that are inside the Earth. Remember, it gets hot down here, rises because it's less dense, it gets cool up here, so it gets more dense and starts to sink back down. And that's why we have this circular motion. And that's why we have tectonic plate movement. All right, this is all going to be useful on our homework assignment for tonight. So make sure that you do it, make sure you submit it, and have a great weekend. Next week we are going to be doing a study guide, studying, and then we're going to have our final test on Thursday. It's been a great time teaching all of you. Thank you for a really, really great year.